Okay, so good morning, everybody, and welcome back to our session on big data. So today we are going to understand what exactly is this big data and whether you should make your career forward in this big data or not, and what are the prerequisites you need to become a very good data engineer. Okay, now about myself, I'm Suraj. I have around 10 years of experience. I've been working in big data since last 8 years. So I have worked on various companies like service-based companies like Capgemini, like small startups, and currently my assignment is with Apple Hyderabad, wherein I do a consulting. And right now I am on a notice period, and I'll be joining a US based startup very soon. Okay, all right, so that's all about myself, and we will take our journey forward. So let's understand what exactly is big data. Okay, so this is a live whiteboard training program, right? And I would not be able to take up your questions right now. Whatever questions you have, please keep till the end, and I will help you answer all of them at the end. Okay, so I'll not be checking my chat box here, and uh, I'll look into that at the end of the session only. Okay, so what is this big data, right? So we heard this term big data since long time, right? And big data, if you say big data is future, you are wrong, right? We are already using big data. I have been using this big data since last 8 years, right? So big data is all about processing the data where the data volume is very high. Okay, now suppose you are given a data set, and let's say the data set is hardly 1 MB. Okay, let's say the data is hardly 1 MB. Now, will you say this 1 MB is can be called as a big data? Not really, right? Because it looks very small. It's not it. So big data is nothing but a situation where you have a lot of data and you are not able to process them in a given time frame. Okay, so whenever you want to classify if a problem statement is a big data problem or not, if a problem is big data or problem or not, then you'll have to consider two things. Okay, you must consider two things. One is the volume of data. Okay, and the second thing is the processing time. These are the two main important factor which can help you decide if a data is a big data or not. Rest all other factors are not that much important, but these are the most important factor if you are given a problem statement and if somebody asks you to classify if it is a big data problem or not, right? Now let's talk about this volume. So suppose I have a data of 100 MB. Suppose I have a data of 100 MB. Now, the first thing is volume. Okay, what is the total size of this data? 100 MB. Okay, now can you store this 100 MB of data in your laptop? Yes, easily. I can even store it in my pen drive. It's not it. So I can store it in a laptop very easily, right? Now, how much time will it take to process this 100 MB of data, right? So for example, let's say you got some data and that is of txt file, and you are asked to write a program to read those data line by line and do something out of it, right? Maybe find out all the employees, if that's an employee data, find all the employees whose salary is greater than 10,000 and they are doctors, right? 10,000 USD and they are doctors, right? So you will write some business logic, is not it? Now, when you execute that business logic, how much time will it take to process this data? And let's say it took roughly 30 seconds. Okay, let's say it took roughly 30 seconds to process your data. Now, in this case, you cannot call this data as a big data. Okay, you cannot call this data as big data because the data is not that much big, as well as the processing time is not that much high, right? It is acceptable if you are processing this data in 30 seconds. Okay, now let's take another example. Let's say you are given 2 terabyte of data to process. That's okay. So let's say you are given 2 terabyte of data to process, and let's say it is taking almost let's say 20 hours to process. Okay, now the question is, will you call this data as a big data? Right now the question is, will you call this data as a big data? Just a minute, guys, let me turn off my internet so that nobody calls me. Better I'll switch off my mobile. Okay, so you are given 2 terabyte of data to process, and let's say it took almost 20 hours to process. Right now, the question is, will you call this data as a big data? Right now, let's understand. See, these days you can even get a hard disk of 4 terabytes. Right? So if I say, okay, I have the capability to store this 4 TB of data in a single machine. Okay, all right. Now, as per my storage, I'm okay. I'll be able to store it on a single machine. That's fine. Now, the second thing is, you are taking almost 20 hours to process this data. Okay, now you should go and check with your organization, with your client, saying that, hey, I can process your data in 20 hours. Do you accept it? Right? And if the client says, okay, I have no problem, if you give me the data tomorrow, that's okay, then you'll still not call it a big data. Okay, so understand this. So see, by looking at 2 TB, you should not close your eyes and say, hey, it's a big data problem, right? You have to understand how much time will it take to process the data. It's taking 20 hours, and your client may not agree, right? Your business, the business may not agree, saying that when you say you are going to process this data in 20 hours, right? Now the problem is, they say, no, we don't accept it. We want you to process this data maybe in really 2 hours. That's impossible for you, right? Because of the volume, you will not be able to process the data in 2 hours. Is not it? But more onto it, this 2 TB of data may not be constant, right? Today you are getting the data, today you are getting 2 TB of data every day. But over the period of time, as the business grow, the size may increase. And if the size increases, let's say after 2 years, this 2 TB of data become 20 TB, right? Now you may not be able to store it on a single machine because the maximum capacity is 4 TB, let's say. So now the problem is, how do you store this data, right? Now you will not be able to store this data, and when you try to process this data, it may take almost 200 hours, right? So now you are into a problem of big data, right? So what is a big data? Big data is basically a problem. Okay, big data is basically a problem which says my data is very, very huge.
I didn't catch that. Could you try again?
Sorry guys, just a minute.
No need to apologize.
All right, so now we are into a problem of big data, right? So this is called as a big data. So big data is basically a problem. Okay, big data is basically a problem which deals with huge amount of data, and you want to process it really quick. Okay, now how much quick can you process the data, right? So you should not say, hey, I want to process the data in milliseconds. That's impossible. Okay, that's really impossible. So we'll talk about this. Okay, what is the real time frame at which you basically can process the data, right? Now let's move on and let us talk about what is this big data and Hadoop, right? This is the very common terminology everybody talks about, big data, Hadoop, right? And we basically confuse ourselves, thinking that big data is Hadoop and Hadoop is big data, right? So but let's understand what exactly is the difference between big data and Hadoop, right? So let me erase this one. So now we are trying to understand what is big data and Hadoop. Okay, so let's understand with an example. Now suppose if I ask you, can you tell me what are the programming languages you know, right? Your answer would be, programming languages I know are Java, C, C++, right? Python, Scala, and so on, right? And if I ask you, can you tell me some of the database software you have ever used? Then you may say Oracle, maybe 11i or 10G, right? And let's say MySQL, right? Maybe Postgres, and so on, right? Now, if I ask you, can you tell me some of the, like web framework you have used, right? You may say I have used GSPs and subnets in Java, right? I have used PHP, right? I have used ASP.NET, right? And so on. Is not it? Now, if you look into this, Java, C, C++, Python, Scala, they are all what? Programming languages. Is not it? They are all programming languages. And this is just a category, is not it? This is just a category. Okay, and these are actual implementation, right? Have you ever written a program to print if a number is prime or not using programming language? No, right? You've either written it with Java or in C or C++ or in Python or Scala, but you've never written it in something called programming languages. Is not it? Similarly, you might have created a tables in your databases, right, and inserted some records and all, but you don't do it on your database, right? So you do it either on your Oracle or in your MySQL or in your Postgres. So what I'm trying to tell you is these are generic terms. These are generic terms, and these are actually the implementations, right? These are basically the implementations. Similarly, if we talk about big data is a term, guys. Big data is basically a term, okay? And this is basically a problem I have told you, right? And Hadoop is one such implementation to solve that problem. Okay, so now you should not get confused. What is big data and Hadoop? They are not same, right? For example, Java is programming language, but programming language is not Java. Is not it? Similarly, MySQL is a database, right? Database management system, but database management system is not just MySQL. Is not it? So similarly, just a minute, guys. Okay, so similarly your big data is a problem. It's basically a category, and Hadoop is one such solution to it. Okay, there are many other solutions, like you have Disco, you have Spark, you have Hydra, and so on. Okay, but these are really popular. It's not, these are really popular. So you should understand that when somebody says big data, it does not really mean only Hadoop. It could be anything else, right? So that is what the difference between big data and Hadoop is, right? So Hadoop is basically one such implementation to help you solve big data problem. And what is a big data problem? Big data problem means either the data is very, very huge to be stored in a single machine, or it will take a lot of time to process that data when you start processing it in a single machine, right? So that's the main difference between your Hadoop and big data. So big data is basically a category, and Hadoop is just one such implementation of it. Okay, all right. So now let's understand what it takes for you to become a data engineer, right? Because I know that there are plenty of information available in the internet. Many informations are not complete. Okay, and at the end of the day, you end up learning something which is hardly used, or maybe which is not all that you are really looking for to make yourself as a big data developer. Okay, so we'll talk about big data prerequisite, what all it takes for you to become a successful data engineer. Okay, so data engineering, right? So see, I have been doing this since last 8 years, right? And then with very varieties of companies wherever I have worked, I'll share my experience, right? So the first thing is you should be good in programming. Okay, so you should pick up one language. I would always prefer Java first. Okay, the learning path, right? So you must learn Java first. Okay, so you should be good at Java programming. Next, now once you're good with Java programming, when I say Java programming, only J2SE is okay. Okay, you really don't have to go and learn the web frameworks like Servlet, GSP, Springs, Hibernate, all those tools. Okay, you really don't have to learn those. You just need to learn Java, right? Next, now you should learn something like Hadoop MapReduce. Okay, and then you should start learning something called ecosystem components. Ecosystem components. And what are the popular ecosystem component everybody uses? They are like Hive, right? Scoop, HBase, Uzi, and many more, right? But these are some of the popular, ecosystem component widely used. Next, now once you're done with this, then you should also start focusing on learning another language called Scala. Okay, and then once you're done with learning Scala, you should start learning Spark with Scala. Okay, And once you're done with this, then you should also learn something like Kafka and possible Elasticsearch. Okay, so that's what you need to have, is not it? Now, along with this, you should also learn a lot of tools, developer tools like Git, Maven, Log4j, JUnit. Okay, uh, right? So these are some of the tools which you should also learn as part of your data engineering program, right? Because see, at the end of the day, it's not like you go to the industry and you say, I know only Hive, I will use only Hive. I've seen many people learning only Hive, calling themselves as a data engineer, right? You'll not be able to solve every problem using Hive. That is what you have to understand. So this should be the sequence of learning. This should be the sequence of learning your data engineering program, right? So I will help you at the end of the day, at the end of this session, I'll help you how can you get access to my 45 plus hours of videos wherein we'll cover the basics of this. Okay, wherein we'll cover the basics of this. These ecosystems are not covered, but otherwise we've covered the basics of MapReduce, Hadoop, Scala, Spark, and all. Okay, so we will talk about that at the end of the webinar today. Okay, so please stay tuned. All right, so this is what you need to have, in your profile, in your resume, if you want to call yourself as a successful data engineer. I know people may say, hey, that's all good, but why not Python, right? Why don't you prefer Python here, right? So see, Python is an extra language to be included, okay, but not the main language to be included. I know there are companies who are also working with Python. They are working with PySpark. I totally agree with you, right? But let me tell you that all good companies or all the best products, whatever you build, okay, they are all written in Java and Scala. Okay, if you don't believe me, Google it out and you will find that Python is older than Java. Python is older than Java. Okay. Now the question is, all these components like say Hive, Scoop, HBase, Uzi, they are all maintained by Apache. Okay. And trust me, they are all written in Java. Right. Now the question is, why did not the inventor of this framework use Python, right, to build Hive, Scoop, HBase, Uzi? Why did not they write it in Python? Why did they prefer using Java? And I believe they are much more smarter than us. We are just a programmer, right? They are the inventors. You have to understand this, right? We just use it. It's not it. And they put their brain and then they develop this kind of framework. So when they built this framework, they preferred using Java and not Python. Now you cannot debate with me saying that because Java is older. No, I've already told you that Python is still older than Java. Google it out and you'll see that it is correct. Okay, so all these languages, all these frameworks are internally designed in Java. So whenever you feel you want to get into the source code of it to understand how does it work, then you should basically know Java. Otherwise you'll not be able to understand the internal code behind it. Okay, so that's the point I wanted to make you here, that Java is must. Okay, if you want to call yourself a good data engineer, then you should know Java. Okay. Now the question is, okay, Java is what we have to learn, and if you learn this Java, then learning Scala would be easy. Learning Scala would be easy because this Scala is internally a JVM based language. Okay, and many concepts from Java is inherited in Scala as well. Right, for example, you want to work with string, you want to work with files, right? You have to rely on your Java string and files. Okay, so that's how your learning curve should be on this data engineering platform. Okay, so whenever you are planning to switch your career, whenever you're planning to make your career in data engineering, please make sure that you follow all these steps step by step. Okay, all right, now let's move on and let's understand more about Hadoop. What exactly is this Hadoop? How does it work? And when did it come to market? And how is it doing really good? Okay, so Hadoop. was officially announced in 2003, right? And then it started getting implemented from 2006 onwards. People are using it since 2006. Okay, and I have seen people implement using it in India since at least 2011. Okay, I don't know if there were people who have started using it in 2011 before 2011, but I've seen that people have started using 2000 Hadoop since 2011 at least. Okay, now Hadoop is basically a framework, right, which is designed by two popular scientists, Doc Cutting and Mike Cafiera. Okay, so these were the two folks who invented this Hadoop. Okay, and during 2003, at that time, these folks were working on some project. Okay, which demanded them to store some data and start crawling the entire web, right? And I think they were working with Yahoo and all. Maybe yeah, yes, I think they were working with Yahoo. So these folks were working on a project wherein they had to collect a lot of data, right, and then do some processing. And the system which they had were really not that powerful. Okay, for example, see, if I talk about 2006, if I talk about 2007, I bought my first laptop in 2007 when I was in BTech second year, right? And that time, the laptop which I had was having 80 GB hard disk, okay, 512 MB of RAM, okay, and it was, I think, dual core processor, right? So this was the configuration which I had in 2007, and that was the latest configuration available publicly for in the market. Okay, now today in 2020, okay, 2015, I got another laptop, right, wherein the system were quite better, and that now this time I have 1 TB of hard disk, okay, and I have 16 GB of RAM, right, and I have 8 cores, right, it is i7 i7 8 cores. This is what I got in 2015. Okay, now in 2020 I got my new laptop, okay, and this MacBook Pro, which has 2 TB of SSD, okay, and it has 64 GB of RAM, and it has 8 cores i9 processor, right? So why I'm telling you this, I'm just telling you this so that you can compare the evolution of computers, right? So see, if you talk about 2007, right, and 2020, what is the difference here? That time it was 80 GB hard disk was the maximum capability, whatever was available. Today you get 120 GB of memory card itself, is not it? 512 MB of RAM. I don't know what can you install, in today's market, right? And that time you need that time Windows XP used to take only 2 GB for installation, 2.5 GB for installation, right? So see, the evolution has been great, right? The evaluation has been really great, and in 2020 you have powerful systems, is not it? So think about these guys who were actually working on the project in 2003, right? They, although they will not use the normal laptop what we use, right, but still their servers are also weak as compared to what we have today, is not it? So these guys were still facing a lot of problem. How do we scale up our system, because every day the data is growing, right, and we're not able to load all the data into the memory, and processing is taking a lot of time, and they had no clue what needs to be done next. Okay, now at the same time there were scientists from Google, okay, there were scientists from Google, and see, all the scientists from Google, they are basically PhD holders from various reputed institutes, right? Now these guys came up with two papers, they published two papers, okay, and they are called as GFS and MapReduce. Okay, so they came up with two papers called GFS and MapReduce, and GFS stands for Google File System, And MapReduce has no definition, like no full form. MapReduce is just MapReduce. So two scientists, not two scientists, scientists from Google, they published two papers, GFS and MapReduce, wherein they said GFS can help you to spread your data across multiple computers. Okay, and MapReduce can have that capability to process all this data parallelly in your system, in your whole machines, right? And this is what these guys were looking for, like Doc Cutting and Mike Cafilera, right? These people were looking for this solution, is not it? And they felt, okay, this paper is out and this idea is really great, and let's start implementing it, right? So see, they have just given an idea means, suppose if you ask me how to prepare a tea, right, I will say you boil water, put some milk and put some tea, put some sugar, wait for 2 3 4 5 minutes, and your tea is ready, right? So I have just given you an idea. That does not mean that I've really given you a tea. It's not it. You have to go and prepare it for yourself. Similarly, these guys have just given an idea that this is what can be done, right? And these guys, Doc Cutting and Mike Cafellera, they implemented this completely from scratch, right? And then the product which they built became Hadoop. Okay, so the product which they built, that became Hadoop. Okay, so the product became Hadoop, right? And in Hadoop, you have two things: GFS became SDFS, and MapReduce is MapReduce. Okay, so in Hadoop, this GFS was renamed because they cannot use Google name anytime, right? Copyright problem. So they named it to SDFS, which means Hadoop Distributed File System, and MapReduce, they gave the same name, right? MapReduce. Okay, so the initial version of Hadoop, whatever they created, had only SDFS and MapReduce. Okay, so let's go back to let's move forward and let's talk about Hadoop right now. So I hope you understood the history of the Hadoop, how it came into the market, and then what were the challenges faced by the scientist Doc Cutting and Mike Cafellera, and how the Google came up with two papers, and these two papers were, like implemented from scratch under the guidance of Doc Cutting and Mike Cafellera, and that product became Hadoop. Is not it? So let me see if you guys have any questions, and then we'll move forward again. So you should not have any problem, from my end, guys. If anytime you get disconnected, if you're not able to hear me, I would suggest you to join it again. Okay, so please join the session again and you should be connected. All right, let's move on. Yeah, let's move on and we will talk about the next. Okay, now we will talk about our Hadoop, right? So as I've told you, that initial version, the very first version of Hadoop that came to that was released, right, had only two components. They are SDFS and MapReduce. Okay, and what does this SDFS means? SDFS means Hadoop Distributed File System. Okay, and what is this MapReduce? MapReduce is basically a framework to process your big data, and SDFS is for storage. Okay, SDFS helps you how to store the data, and MapReduce will help you how to process the data. Okay, now let's talk about the concept of node. What is a node? What is a cluster and all, right? So see, basically what happens, when you are trying to process the data in a distributed environment, usually you will have to create a network. Okay, so usually you will create a network, let's say a network of 5 machines, right? And each of these machines have their own CPU, right? Have their own memory, have their own hard disk, not really necessary, but usually we have, okay? And they are a computer on its own without display, right? So they are all computers. So each computer is called as a node. Okay, they're all called as a node. Node 1, node 2, node 3, node 4, node 5. So all these computers, each and every computers are basically called as a node, and they are basically a computer, on its own. They have their own CPU, memory, as well as hard disk usually. Okay, and when they are connected to a network, they create a cluster. Okay, so cluster is nothing but like combination of more than one computer together. Okay, and all these individual computers are called as nodes, is not it, and they are all connected together. Okay, now when we start processing this, when we want to process this data, when we want to process a big data using Hadoop, then usually what happens, we create a cluster. Okay, how big a cluster can be? Google says they have 4,000 node cluster, right? So you can have like you can have 4,000 node cluster easily, but it needs a lot of money, it needs a lot of investment, right? Usually a company prefer having 300 node cluster, 400 node cluster. Small companies may have 10 node cluster, 5 node cluster, and so on. Okay, everything is possible based on your data set, based on your requirement. You can go ahead and increase the total number of nodes in a cluster. Okay, so these are all nodes, and in each of this machine, we will basically install Hadoop, right? And then they will start working together. Okay, so when we say SDFS is what? Distributed file system, which means what it does, let's assume that this node has 1 TB hard disk, this has 1 TB hard disk, 1 TB, 1 TB, 1 TB. Let's say all of them, all these 5 computers have 1 TB hard disk each, right? So in that case, my cluster will have 5 TB space, which means I can store the data in this cluster. I can store at least 5 TB of data, right? In this cluster, I can store at least 5 TB of data. When you are storing the data in this cluster, the data would be broken down into multiple parts and they will be stored chunk wise. Okay, the data would be stored, the data would be first divided into pieces, and those each pieces would be stored. Let's understand let's understand how the data is basically stored in this system. Okay, let's understand how the data is basically stored in this system. Okay, now suppose, let's say you have a file of 1 GB and you want to store this data. Okay, so I have a file of 1 GB, I want to store this data in this cluster. Okay, so 1 GB, right? So see, 1 GB you can easily store directly here, is not it? Because all this machine have a capacity of 1 terabyte, right? And you can easily store this 1 GB in this in these machines, right? But that does not happen in Hadoop. Okay, what Hadoop does is, in Hadoop you have a concept called block size. Okay, that means your data would be broken down into small blocks. Okay, your data would be broken down into small blocks. Let me give you an example to help you understand more better. Okay, so let's say there are 500 people who wants to go from place A to place B. Okay, and let's say the bus capacity is only 100, right? The bus capacity is only 100. So if the bus capacity is only 100, then at any time you cannot really put 500 people there, right? Bus capacity itself is 100. So what you need to do is, you need to bring 5 buses, is not it? 1, 2, 3, 4, 5. Okay, you need to bring 5 buses, and in each bus you keep 100 people, right? You ask 100 people to get into the bus, right? And let the bus move, and that's how you will be basically able to move 500 people from place A to place B, right? Otherwise what you could do is, you can take only one bus, but you'll have to do a lot of trips, right? So first, in the first trip, you send only 100 people, the bus will return back empty, again another 100 people, again it will return back empty, another 100 people, and so on. It's not. Similarly, when you want to store the data in SDFS, your data will not be stored as a single chunk. Okay, these data would be broken down into pieces, and that would be decided by something called block size. Okay, so Hadoop currently has 3 versions: Hadoop 1, Hadoop 2, and Hadoop 3. Hadoop 1 block size is 64 MB. Hadoop 1. Okay, whereas Hadoop 2 and Hadoop 3 version, they have block size of 128 MB. Okay, you can also configure this to 256 MB, 512 MB, and so on. All right, so now if I say 1 GB of data, and let's say my block size is 128 MB, right? Now 1 GB means 1024 MB, and you want to store this data in SDFS, and I have told you that the data would be broken down into multiple pieces, and each piece would be maximum of 128 MB as per the block size. If you increase the block size, definitely, like the number of pieces would decrease. Okay, so 1024 MB by 128 would be 8, right? Which means 1 GB of data would be broken down into 8 smaller chunks, and these chunks are called as block, right? So B1, B2, B3, B4, B5, B6, B7, and B8. So you have 8 blocks, and all these 8 blocks are basically, all these 8 blocks basically hold some data, and they are of size 128 MB max. Okay. Now, instead of 1 GB, if you, let's say you have 200 MB of data, then what will happen? This will be broken down into 2 blocks. Okay, block 1 will hold 128, block 2 will hold the leftover, that is 72, right? Now in our case, if we have 1 GB of data, 1 GB of data would be broken down into multiple chunks, and each of these chunk would be stored on your machine, okay, in a parallel fashion. Which means now this b1, b2, b3, how it will be stored, let's understand. Okay, so b1, b2, b8, so see how it will be stored. B1 might get stored here, b2 might get stored here, b3 here, b4 here, maybe b5 here, maybe b6 here, okay, maybe b7 here, maybe b8 here, something like this. Okay, so they will be stored randomly based on the spaces available across these machines, right? So that's how the data would be broken, and that would be stored. Now you may ask me, hey, why are we even breaking this data into multiple part, right? Why did not we just store it here? The reason why we did not store it here is in a single machine is because it's not just about storage, it's also about processing. I want to process this data as much parallel as I want, right? And that is the whole reason why the data are basically broken down into multiple pieces. Okay, now for example, suppose you have 100 GB data. Let's assume, okay, suppose you have 100 GB data. Suppose you have 100 GB of data, and if you want to really store it on your Hadoop cluster, then how many blocks it will be created? See, 1 GB was divided into 8 blocks, right? So 100 means 800 blocks, right? 100 means 800 blocks, and I know that no machine will have 800 cores. We are not that much advanced today, right? We may have hardly 40 cores, 50 cores, and so on, but no machines would have 800 cores altogether, a single machine these days, right? So in that case, you will not be able to process your data very parallelly, right? And that's the reason what Hadoop says is, whatever data you give me, I'll break it down into chunks so that it can be spread over the cluster. Okay, now suppose I have 800 blocks, right? Let's say this cluster is actually 1000 node cluster, let's assume, right? That means I can easily store all these blocks in many machines, and I can start processing it parallelly. Is not it? Even I may say I have a 200 node cluster, right? And let's say each node has 8 cores, 8 CPU together, each machine, right? So altogether you will still have 1600 CPU, right? And you can still process the data very parallelly, right? And that is the reason the data are basically broken down into blocks, and they are stored across, even though 1 GB you could have easily stored on a single machine, right? Because it's not just about storing the data, it's also about processing the data parallelly. Okay, now when you store this data, right, when you store this data, it is practically possible that while you are processing, your node may go out of service. Your node may go out of service. It is practically possible, right? And Hadoop says, yes, it is purely possible that we may lose the node, right? Because they are all in network, and you don't know what will happen to a network, right? So to avoid that problem, Hadoop has a concept of replication, okay, which means the data should be duplicated multiple times. How many times, that depends on you, but by default the replication factor is 3. Okay, I'll write it here. Replication is equal to 3 by default, which means your data would be divided into 3, your data would be duplicated 3 times, and multiple copy would be maintained in the whole cluster, which means b1 is stored here, right? What will happen is one more copy of b1 would get stored somewhere else. Okay, b2 again, one more copy would be stored somewhere else, right? Similarly, b2 is here, so one more copy would be stored somewhere else. Okay, like this, right? Now in case this machine is out of service for any reason, then also no worries, because you have lost b1 but you already have a copy here as well as here. That's not it. So we can still get the data from some other node, and that is why the replication will happen. You may ask me, hey, replication is okay, I understand, but don't you think this is going to consume a lot of space, right? We are unnecessarily wasting a lot of space. But I would say the disk is really cheaper these days, right? And that's okay if I'm losing if I'm using it, like if I'm losing some space, that's absolutely fine. But what should I not lose is the data, right? And that's how Hadoop 2 has like Hadoop 1 also, like that's how Hadoop has a concept of replication factor. Okay, now in Hadoop 3 there is an advanced technique called eraser. Okay, eraser coding, wherein you really don't have to waste a lot of time, a lot of space to store the data. We'll talk about that in some other day. Okay, now that's what we have in Hadoop, right? So you have a concept of replication factor, wherein you can say, hey, I want to store my data, and Hadoop will take care of storing the data for you. They will replicate your data so that at any given time frame you do not lose the data even though the machine goes down. Okay, all right. Now let's talk about one concept called scaling. Okay, so as I've told you, during the early days when dog cutting and MyCafe era were trying to, like process the data, every day the volume of the data was increasing, right? And they were finding it very difficult to store the data as well as process that, right? So sometimes they go out of the disk, sometimes they feel memory is not sufficient, sometimes they feel the codes are really not great. Okay, so every time what they started doing, they started upgrading it, right? For example, if I say you have a laptop, okay, and your laptop has 80 GB hard disk, right? And let's say you have 4 GB RAM, okay, and let's say you have 2 cores. Okay, and let's assume you have that facility to upgrade them, right? Upgrade them means remove this and put something else, remove this and put something else, remove this and put something else, right? So when you feel that your system is not capable enough to do the work, what you'll do, you may go and say, hey, 80 GB is not sufficient, I'll put 160 GB. Okay, and you may say 4 GB is not sufficient, I will upgrade it to 8 GB. Okay, and you may say 2 cores are not sufficient, I'll upgrade to 4 cores. And let's say your work is all going good, right? After a few months you'll again hit this space issues, right? So you may say, hey, 160 is not enough, let me make it 320. Okay, and you may say 80 is not enough, let me make it 12. Or you may say 4 cores are not enough, I want 8 cores now, right? After again a few months you may again come to the same problem, right? So what you are doing is, whenever you are facing any problem, you are constantly upgrading your machine, right? Upgrading your machine, but upgrading your machine has a problem. And what is that? You cannot upgrade it to whatever extent you want, right? Because the hardware has a limitation. I cannot go and say I want 1 TB of memory, right? It is not possible today. I don't know it will be possible when, but it is not possible today to have 1 TB of RAM in a single machine. It's not it. For example, as I told you, when I bought my laptop, my laptop had 512 MB of memory, right? Now today I have a 64 GB of memory. Now see how powerful the systems are over this period of time. So tomorrow you may see 1 TB of uh, memory, right? It should not be a big deal tomorrow, but today we don't have it, right? So when you're constantly adding a lot of when you're constantly upgrading your machine, your upgradation may not like you may not be able to upgrade it as per your wish, because you will hit the hardware limitation, is not it? So this is what we call vertical scaling. Okay, this is what we call vertical scaling. What you're doing is, see, you are trying to grow your machine vertically. This is vertical, right? This is a vertical line. So you're trying to grow your machine vertically, right, by adding more power to it. Okay, now Hadoop comes with a concept of horizontal scaling. Hadoop comes with the concept of horizontal scaling, which means whenever you feel whenever you feel you need more space, you need more machine, right? So just add them. You just add them. Don't try to upgrade it, right? Add one more system, add one more system, add one more system. So in this case, you are growing in this direction, right? More systems, right? So this is what we call horizontal, right? So Hadoop says believe in horizontal scaling, because when you add one more machine, you get brand new CPU, you get brand new memory, you get brand new hard disk, right? And that's what we actually need, right? So in Hadoop, you can also do vertical scaling as well as you can do horizontal scaling, right? If you feel you want to upgrade, the configuration of each of these machines, then you can go ahead and update it as much as you can, right? Whatever is the limitation, you can make it to the highest level. Then if you feel it is still not sufficient, you start adding more machines, right? And that's what we call horizontal scaling, right? So I hope you understood the concept of SDFS, how the data is basically broken down into pieces and how they are basically stored in a cluster, how the data is replicated, so that if at all you lose any data at any time, you should be still able to process the data because the data is present elsewhere, right? And we understood how how the Hadoop clusters are basically scaled horizontally instead of just scaling it vertically. Okay, let's move to the next topic. Let me see if you have any questions here. Okay, now let's move on. So I'll come back to all your questions, right? Because if I feel I should answer it immediately, I would take it up immediately. If I feel okay, I can answer it at the end of the day, then I'll wait and we will answer that at the end of the session. Okay. All right. Now let's talk about we spoke about SDFS, right? We understood how the data is basically broken down into pieces. Now let's talk about MapReduce. Okay. Now in any Hadoop system, what we have is we have nodes. Okay, we have nodes and we have some masters. Okay, so if I talk about Hadoop 1, then we have name node, we have secondary name node, we have job tracker, and we have data node, and we have task tracker. Okay, what are these? These are basically the process. These are basically the program which will run when your Hadoop is up and running. Okay, so your SDFS would all be maintained by your data nodes. This process is responsible to manage your SDFS file system. Okay, so when I say 1, 2, 3, 4, 5, 5 node cluster, right? 5 node cluster, and this will help you to create the data nodes. This will help you to create SDFS in your file system. Okay, now this task tracker will basically help you to process the data on this storage. Okay, so now this name node would be basically a master which will keep track of all your like namespace metadata. What are the total files in our Hadoop system, how many blocks they are divided into, right? So all these informations will be maintained by your name node, and secondary name node can help if the name node crashes, right? So you can just take the backup. Secondary name node just takes the backup of name node in a frequent interval and always helps updating the namespaces. Okay, and this job tracker is where client submits the job. So whenever you write a program, when you write a MapReduce code, okay, so the typical MapReduce codes are basically written in Java. Okay, I believe you can also write it in Python, but I have never tried it out. Yes, so you can of course write it in Scala as well. I've tried it. Okay, so MapReduce is what you write in Java or Scala. Okay. Even you may work with Hive. You write your Hive queries, and your Hive queries gets converted into MapReduce internally. Okay. So at the end of the day, what you have is a MapReduce job, which would be in terms of jar file. Okay. You create this on your IDE like Eclipse or IntelliJ, and then you create a jar file out of it, and then you submit the jar for processing. Okay. So when you submit the jar for processing, what happens? This jar file would be submitted to your job tracker. Okay, and this job tracker would send that mapper and reducer code to these machines. Okay, this job tracker will send the mapper and reducer code to these machines, and these machines will start processing your data. Okay, now Hadoop believes in processing the data locally as much as it can. Okay, which means, see, basically you are going to deal with terabytes of data, gigabytes of data, right? And it's always advisable that you don't move around with too much. You don't move around too much of data in your network, right? Because data movement would take a lot of time, is not it? And that's the reason in case of our big data Hadoop, what happens is your program code runs, your program code travels, your code travels to the place wherever your data is present. Okay, and we don't move too much of data, but I did not say we don't move data at all, right? Data movement happens, but you will have to make sure that the data movement is minimal so that you can get the data processed very very fast, right? So you have created a jar, and that jar goes to the slave computers. These are the master, and these are the slave computers, and the data will be processed in your slave computers, right? So in Hadoop 2 and 3, this job tracker is not there. But what we have instead of this is you have something called resource manager. Okay, and task tracker you don't have it here. What you have is you have something called node manager. Okay, so this you will learn in your Hadoop architecture 2 and 3. Okay, so at a very high level, this is what we have. You have a MapReduce program, and you write a MapReduce program on your own, and then you submit it to the cluster, and it runs your program, and it gives you the output at a desired location, right? So you basically will take the data. You'll basically read the data from SDFS, and you basically write the data to your SDFS. Okay, but the source and destinations can be different as well. If you want to read the data from database and store it on SDFS, possible. You want to store the data from some data, you want to read the data from database, and you want to store the data back to the database, that is also possible, right? But at the very high level, this is how your MapReduce will work. You write the program, submit it to the cluster, and this would be the code will travel, not the data, right? The code will travel, and once the code is present on your machine, they would be executed under the guidance of task tracker. Task tracker would basically run the program, right? So every MapReduce program has two components: map and reduce. Okay, there are other components as well, but the major, the most important two component are MapReduce. There are other components like you have combiner, you have partitioner, right? But if you see at the very high level, MapReduce has two components at a very high level: map and reduce, right? So map would process the data for each line. For example, if you have a data of 1000 lines, then by default, okay, see, this all can be customized. So I'm talking about the default configurations. By default, the map will have the capability to read this 1000 lines line by line. Okay, and they will start emitting some data, and this reduce will read the data whatever was given by your map. So map would be the first guy reading your input file. Okay, and the output from this map will go to the reducer, and reducer will start processing your data further, and the output of your reducer would be the final output. Okay, it is also possible to run only map job without the need of reducer, but you will see them as part of our 45 hours of free course program itself. Okay, so I hope you are clear with the concept of MapReduce, how exactly the MapReduce work, right? So you basically write some program, you learn how to write the program, okay, in our free course, and then you should be able to submit that programming into the cluster, right? Okay, and then you'll be able to correlate this very, very well. Okay, all right. Now let's move on to the next topic, that is ecosystem components. So let's talk about ecosystem components. So we have ecosystem components. Okay. Now, as I have told you, the very first time Hadoop came into market, we only had MapReduce to process the data, right? SDFS is to store the data and MapReduce is to process the data. Now the problem is MapReduce needs Java, and not everybody is seriously interested to invest a lot of time learning those difficult Java syntax to process the data. Okay, is Java difficult? Not really. Okay, but it depends on how do you really look into it, right? But for the people who have almost 20 years of experience and they were doing a lot of things in SQL, they may not agree to write a Java program, right? Because they may feel, hey, I have a data which is basically like a tabular kind of data which I can like express in terms of rows and columns. Can you give me really quick some SQL kind of syntax which can be used to process the data, right? So for them, many people started building components, okay, which can internally execute a MapReduce job and get your work done, which means at a very high level, if you say, hey Suraj, I know only SQL query, will I be able to work in big data? You can do certain amount of tasks. You cannot be a complete data engineer with just SQL query, right? So now in ecosystem component we have a lot of tools. You have like Hive, you have Pig, which is outdated now, nobody uses, so I don't prefer talking about it as well. So you have Scoop, you have HBase, you have Uzi, and you have done many modes, right? But these are quite popular, so let me erase this whatever we don't talk about, right? So Hive, Scoop, HBase, Uzi. So this Hive is basically for people who says, I'm really good at SQL, can you give me some sort of UI or some sort of place where I will write query like select star from this group by this and that, and I should be able to process the data, right? So the Hive is the place where you write SQL query, okay, and internally that would be converted into MapReduce job and will be processed, okay, will be processed by the framework. Okay, now you may have a requirement sometime like you have a lot of data in database. Every day you get a lot of data, like from various sources, and they're all stored in your database. And now you want to bring that data from database to SDFS. Okay, so you can use Scoop to get that done. So Scoop can be used to import or export data to and from SDFS. Once you have the data in SDFS, then you go ahead and execute it using your Hive, because Scoop can be used to import and export the data from database, right? Which means you have the data in a tabular format, right? And if you have the data in tabular format, bring it to your SDFS, and then you can use Hive to run your query on those data, right? Or you can even go back and write your typical MapReduce program if you want to solve it using a MapReduce approach. Okay, next. HBase, right? So HBase is basically what see, Hive can store the data in a tabular format, right? But you might have heard that Hadoop has the capability to process the data or to store the data which is unstructured, is not it? So that time you can use HBase. And what is this HBase? HBase is basically a tool which can be used to store the data which are really not structured, which means let's say the first column has five, let's say the first row has 5 columns. Okay, 5 column, 1 2 3 4 5. Let's say the second row can have 10,000 columns. Okay, let's say third has only 2 columns, right? So if you see this data looks like they are not structured, right? Like every record has like varieties of fields, is not it? Every row has there is no guarantee that you'll have similar number of exact number of columns for every row. So in that case, you can go ahead with something called HBase, or you can also prefer using Cassandra, right? So they are basically what column family based ecosystem component where you can store the data in which are not structured. Okay, so either you use HBase or you use Cassandra, choice is yours. Uzi can be used Uzi can be used uh, when you want to schedule your job. Okay, when you want to schedule your job, for example, let's say the requirement is something like this: every day at 9 o'clock early morning, okay, somebody sends the data to my SDFS in a particular location, and I want a job to be executed every day at 9 a.m., right? So that means you want to do some scheduling, isn't it? So this can be used when you want to do a scheduling. When you want to schedule a job, and let's say every day at 9 a.m., I want to pick the data from some SDFS path, right? So you can use Uzi to schedule your job. Okay, so this is what we basically call as an ecosystem component, which goes around, and then whatever you write, they basically gets converted into MapReduce job. For example, if you say Uzi, whatever job you run by default would be a MapReduce job, right? You can also configure your Uzi to run Hive or Pick script and so on, but at the end of the day, Hive and Pick by default would be a MapReduce job itself. Okay, now these days everybody is going crazy learning a technology called Spark, right? Every day people are going crazy learning the technology called Spark. So let's understand what exactly is this Spark, right? So see, the problem with this ecosystem components or the MapReduce is they read the data from SDFS, process the data, and stores the data back to SDFS. And SDFS is what? SDFS is nothing but the hard disk, is not it? Now the problem is when you are processing a large chunk of data, every time you're reading the data from SDFS, means from your hard disk, processing it and then storing it back to your hard disk, right? And let me tell you, you spend a lot of time reading the data from hard disk to your memory, and memory to your hard disk. Okay, that is the biggest problem of your MapReduce. Okay, in MapReduce, what we have, you have the data in your SDFS, right? And you start processing by using some MapReduce job. Okay, and once your job is over, the output of this would be basically written back to your SDFS. Okay, again, if you have another MapReduce job, you'll again start reading the data from that SDFS, and you'll process this data. Again, it will be written back to your SDFS, right? So read from disk. Okay, and again, after this is done, write to disk, right? And this SDFS is basically the file system which are created out of your hard disk, is not it? And this is what makes your map really slow. People say Spark performance is very fast. The reason is because in case of Spark, what happens? Initially, you have the data in your SDFS, okay? And then you write your Spark job, right? And once your Spark job is complete, that data, the data which you are processing be would be kept in your memory. Okay, the data would not be pushed down to your disk, right? So the data would be present in your memory, and from your memory you again write your Spark job too. Okay, and then you start processing this, and again you will hold the data into your memory. Okay, and on it again you process your Spark job 3. Okay, and finally once everything is done, you may be interested to store the data back to your SDFS for your permanent storage. Is that it? So in this case, if you see, Spark is performing better only for a reason that it stores the intermediate data in your memory, right? it stores the intermediate data in your memory. That is the only reason why Spark is quite better, right? Of course, see, Hadoop is quite old, right? And Spark is relatively newer than Hadoop, right? So the inventor of Spark, they have gone through all the limitations of Hadoop, and they have made sure that all these limitations in Hadoop should be taken, all the limitations in MapReduce should be taken care by your Spark. Okay. However, even if you're learning Spark, you still have to go back to your SDFS, because this SDFS is a part of your Hadoop, right? And Spark do not have their own processing framework. Hadoop has a processing framework called SDFS, right? So can I say Hadoop has two component, MapReduce and SDFS, okay? And this MapReduce is only replaced by Spark, okay? And Spark will still use SDFS to process the data. My data would be stored still in SDFS, okay? And moreover, Hive, Scoop, HBase, Uzi are still used in the industry. So people, if you hear people saying that, hey, Hadoop is gone, it's all Spark now, right? Ask them this question: don't you use Scoop and HBase in your project, right? It's possible that few people are not even using it, right? Depends on the use case. But what I'm trying to tell you here is only MapReduce is gone, right? Otherwise, all the ecosystem component, whatever you are doing, will remain as it is, right? They are as it is till today. People prefer using cloud as well, right? But the cloud is not so cheaper, and that depends from client to client. For example, if you want to work with any government, if you are working on any government based projects, right, they don't prefer using cloud for the data security breach. Okay, they say, you tell me how much money it will cost, I will buy the server on my on my place. I'll hire the engineers, bring them up and running, and you start processing the data from there itself. We cannot give you the data, right? So it depends on the use case. If people want to use in-house Hadoop, or people want to go ahead with cloud-based Hadoop, or people want to go with the cloud-based solution like AWS and Databricks and all, right? But at the high level, what I'm trying to tell you is all these ecosystems are really, really important. Okay, and it takes fair enough time to master each one of them. Okay, let me see if is there any question. Okay, now let's talk about one more thing here, that uh, if Spark is so fast, do you think company are still using the MapReduce? Okay, so see, these days you may not write the MapReduce code, okay, but I would say learning MapReduce will still help you a lot. The reason is many things in Spark are also using MapReduce libraries. Okay, see, the simple word count example cannot help you to realize that, but when you are working on a good projects, then you will see, in one or other place they are internally using the API and libraries of Hadoop MapReduce, right? And then if you want to dig deep into it, then you should have a knowledge about it, otherwise you'll not be able to dig deep into it. Okay, now having said that, see, implementing the Spark solution will always be costlier than implementing a Hadoop MapReduce solution, because in Spark you have to put a lot of money buying powerful memories, right? You need to spend a lot of money in buying memories, whereas in your Hadoop MapReduce you just don't care about very large memory. For example, if you're using Hadoop, right? Let's say you prefer using 16 GB of memory. Okay, whereas the same thing if you would like to do on Spark, then you may say I need at least 120 GB of memory, and memory would be costlier than hard disk, is not it? So depending on the use case, companies are using MapReduce as well as companies are using Spark. When I say MapReduce, that means I write a typical Hive query and let it run in a MapReduce mode. I'll not even like convert that into Spark, or I will not even convert the engine to a Spark engine, because as I have told you that Spark, if you want to implement that, it will really come with a cost, right? So it depends on the use case. People may prefer using a Spark cluster, or people can use Hadoop MapReduce based cluster, but they may not write Hadoop, they may not write a MapReduce program, they may write Hive queries and still process the data, right? So that depends on the use case, that depends on the client, that depends on the requirement, what exactly the client is going to choose. Okay, now see, there is no such use case where I can say your MapReduce will work better than Hadoop, better than Spark, right? But what I'm trying to tell you is, suppose if the requirement is, I want to find out, I want to do some processing of last 20 years of data, right? And let's assume last 20 years of data is really very huge, right? And I'm okay to run my job for next 10 days. I really don't care. I'm okay if I get the output after 10 days. Then why do you really want to invest a lot of money, right, to hold all the data, of 20 years into a memory? Because it will cost you money, is not it? So I will not say that MapReduce can do certain things quite better, but what I am trying to tell you is MapReduce is been used in the industry since longer time than Spark, right? And whenever there is a batch oriented jobs wherein you don't have a time frame, then you can go ahead with the MapReduce approach. Write your Hive queries. If you don't want to write a MapReduce job, write a Hive queries and then get your work done, right? But again, I have told, as I have told you, Hive cannot solve all the problems. If Hive can solve all the problems, then why are we even learning programming language, right? So you can still learn SQL queries, and your SQL queries would be able to solve all the industrial problem, right? Why are we learning Java or Python or Scala, right? So programming language is programming language, and SQL queries are SQL queries. You cannot really compensate them anywhere. There are few scenarios which can be achieved easily using SQL queries. Go ahead with your Hive. Okay. All right. So that's what we have in this ecosystem discussion, where you understood what exactly we have, right? Okay, now let's talk about certifications in big data. Okay, because this is also important. People who are learning big data, they may want to write some certifications. Okay, so see, your Hadoop and all the ecosystem components, whatever you can think of, are all owned by Apache. Okay, and what is Apache? Apache is basically a company, an organization who maintains all these projects for free, right? Which does not mean that their developer are not getting paid, right? They give you it, they give it to you for free, but they have their own technique of generating the revenue, right? Now there are companies, see, you have Apache Hadoop, which is free. Okay, and if you want to practice, you can download this Apache Hadoop. You can install, you can create a multi-node cluster and use it as long as you want to, right? But the problem is, what if there is any problem in this Apache Hadoop, right? Let's say you are processing client's data, and then there are some issues which you are facing because of this new release of Apache Hadoop, right? And if you face any problem, you cannot go back and reach out to Apache Hadoop, because they cannot support you, because it is free. They don't want to take this headache. It's not it. So taking that advantage, we have companies like Cloudera, right? Hortonworks, they would be merged, they are merged together. And then you have Databricks. There is something called MapR, right? And like distributions. Okay, these are basically the companies. These are basically companies which says don't download the Hadoop directly. Okay, we will give you a customized Hadoop. Okay, we'll hire engineers in our organization, and we'll make sure that, like, our Hadoop, whatever we give you, would be better than just the raw Apache Hadoop. And if there are any problems, then we have our engineers to solve that out. Okay, so they have started this, right? So all these companies are basically called as distributions. Okay, and like, people prefer distributions based on the requirement. Few people go with Cloudera, few people go with Databricks, few people go with MapR. Like earlier, I was working with Optum were using MapR, right? And right now, when I'm consulting with Apple uses Cloudera. Okay, so that's how, like, basically companies are using. So see, there is no such best or worst. There is nothing called good and bad. It's about a choice, is not it? For example, you may prefer using Nike shoes, or you may prefer using Puma shoes, right? There's nothing called good and better, right? So that's how it is. So all these companies, they have their own certification. They have their own certification. The syllabus keeps changing, right? And like based on their curriculum, the syllabus keeps changing. And which one is better? See, there is nothing called better and worst. Okay, you can go ahead with the Cloudera certification, CCA 175, or Databricks or Mapr. Anything is okay as long as like you are good in the subject, right? But see, even if you clear the certification, right, you don't get a job directly. Nobody will say, if you have certificate, come to us and take the offer letter of this, right? No, right? So certification would be an added advantage, but not the mandatory advantage. Yes, if you are in US or if you are in other country, people prefer that you have a certification, right? So in that case, you can go ahead with any certification, right? So choice is yours. But I would say, at a personal level, don't spend money from your pocket to write a certification, because a piece of paper will simply cost you 20K plus at least, right? So that's what I'll say. Like, if the company is sponsoring you, go ahead with that. But otherwise, if you're a fresher, or if you are in India, then you really don't need to have a certification. Okay, which certification I have completed? None of them, right? And I'm happy not to be certified. That's absolutely okay, because at the end of the day, what matters more is your experience, right? The way you are learning, the way you are growing every day is your better certificate, right? Then a piece of paper saying that this guy knows this and that, right? Okay, so that's what we have from the certification point of view. Choice would be yours. If you want to go ahead, just look into the syllabus, because the syllabus keeps changing, right? Look into the syllabus, whatever better you feel, you can go ahead with that. Okay, now let's talk about how much is the opportunity of this data engineer in India, right? So see, we have a lot of good requirement in data engineering in India, at least. Okay, I personally know a couple of companies who hires data engineers, and they reach out to me saying that, Suraj, we need good data engineers, right? But problem is, I'm not able to provide them better data engineers, because all the students whom I personally give training, they more or less, if they are serious, they get placed in good companies if they are serious, right? Now, if they see, like, uh, let's say I taught 30 people. Okay, out of these 30 people, 5 people are damn serious. They work on all the assignments, do everything, learn everything in great details, right? And their placement is 200% guaranteed, because they are putting effort, right? Now, maybe remaining 20, 30 people, remaining 25 left. Out of 25, maybe 5 people are okay, right? Now, they also get job, but like, they get job after some time. Okay. Now, let's say there are 20 people who just attends the class and do not work on the assignment or anything. Now, for them, placement is impossible. Okay, unless and until they don't again push themselves hard, it is very much impossible, right? Now, the problem is, all the good students who are a part of my training program, they already get job in good companies, and I'm not like, they are all blocked now, right? Now I can help these people, okay people, right? And the remaining people who are not putting effort, I cannot help them anytime, right? But I still keep getting a lot of calls from many companies saying that we are looking for data engineers, good data engineers, right? So what I do is, basically I say, okay, let me see, and if I get some good people around me. So if you feel you guys are good enough, you can always reach out to me, right? But there would be, like, some sort of assessment before I refer your profile to them, because I cannot really, like, uh, I cannot really, send anybody there, and then they will come back to me and say, "Hey, what kind of candidate you have sent? They're good for nothing." I really don't want that to happen, right? So there is plenty of opportunity, but the problem is, see, out of 100, let's say there are 100 openings. Let's say there are 100 openings. Out of this 100 openings, like, maybe 1,000 people apply, If there are 100 openings, then maybe 1000 people apply, because everybody is learning data engineering and everybody is teaching it, is not it? Now the problem is, still, this 1000 people, we are still not able to close the requirement. So there were 100 openings in a company, 100 candidate applied, but still only 20 people were selected, remaining were not. And trust me, this is the fact. You may not trust me, but this is the fact, that people are just learning anything crap, and they say, they call themselves a data engineer. All they know is high queries, right? And as I'm telling you, high query cannot make you a data engineer. You are still a SQL developer. You have to understand that, and no company would put a lot of money to hire a SQL developer, right? So you will have to understand this. So I have given you the syllabus, right? So the whole syllabus. What you should do is, you should prepare those syllabus, right? So you should prepare as per that syllabus. Every topic, whatever I've told you, you can easily YouTube it, and there are a lot of videos, tutorials available. The API documentations are available, books are available. Of course, you can come to me for a personalized coaching, which we conduct, and my session would be like this: a live whiteboard training program. Okay, so I've already started a batch on December 5th. You can definitely reach out to me personally if you want to be a part of it, but I don't force anybody to take my course. It's completely up to them, right? So you can go through the syllabus I've already given you. You have to prepare all these topics one by one. Okay, now as part of this program, OLC will help you with 45 plus hours of free course on Big Data, Hadoop, Spark, Scala. Okay, which will help you to become somewhat better, and then you can take it forward on your own, right? Otherwise, you can also come to me for a personalized coaching, which goes for at least 10 months. And here you become a solid like this. Five people. I want you to become a solid 5% of the people. You should not come to me if you belong to this category, because you are wasting your time and money, right? So you can come back to me if you want to see yourself as 5% of the people. And trust me, no institute can give you a 100% job guarantee, right? Even I don't say that you'll get a job 100%. Only these people can get a job. Maybe these people can also get a job, but these people will never get a job, right? And I've seen many people, they join my group every time, and they don't even join the classes. They don't even take the advantage of this 45 hours of session. Okay, so that's what I have for today, guys. So I hope you are clear with with what is a data engineering and how does the data engineering can help you, right? So let me go back to my system. I'll share the screen and I'll show you how can you get access to the 45 hours of session, and then we'll close for the day. Okay, so let me tell you where exactly you should start with. Okay, so the first thing is, I'll share my screen. All right, so if you're completely new and you don't know where to start with, I would suggest you to start from here. There cannot be anything better than this. Just a minute. Yes, start from here and grab this, click on this button. Okay, so till December 31st, this is 60 hours. After December 31st, it will be 45 hours. We wanted to give extra 15 hours to the people who really do really well, right? And this will be expired in 31st December. Okay, let me see if we can consider it for a month again, but that's how it is right now. So we had almost 2500 participants who took this first 45 hours of free course. And there you will see all these concepts, whatever I've told you today, high level, right? What is a Hadoop? How do you install it? It's taken care of. How do you, store the data? How do you write a map reduce program? How do you, do this? What is the code you should write in mapper? What is the code you should write in reducer? What is Hadoop architecture 1 and 2? Everything is covered on this program. Okay, and then you have Spark Scala, the fundamental course as well. So you can start learning it from here. Okay, this is the first thing I want you to do. So if you are in your system, please do it right away. So I'll share you this link. I'll share you the link here. Okay, so this is the link which you can start. right? So this is the link which you can start, and I would suggest you to first finish this, like, right? So see, don't look into the internet is so wide that it will confuse you. There are so many people teaching so many technologies. I will not say everybody is wrong, right? But what happens, like you get confused. Like, follow one direction, right? Choose one particular channel. Any channel you can take. You can take my channel, you can take somebody else's channel. Take one channel and start learning it step by step, right? Otherwise you'll get confused. So many people are producing videos, and you'll get confused what to learn and what not to learn, right? So that's what I would say. Okay, now as I have told you that we have started this whiteboard training program, where I will basically be teaching it like this. Just a minute, the internet is really slow because of this Wi-Fi. So if you see, if you enroll to that program, you'll start getting access to core Java fundamentals, Hadoop basic fundamentals, and all these are now whiteboard sessions. So these are all the recently started session, and I have tried my best to put as much as possible here. I'll put more videos here, and you can just follow them sequentially one by one. Okay, and that's how it is. So once you're done with this course, you'll be able to collect your certificate. You can put that in your program, saying that I have done some course on big data, right? But you cannot use that as an experience. If you are an experienced guy, you should never say that I have done a course from here and there. Otherwise you are caught, right? You should always say that I have a working experience on it.